Electric field due to a system of charges. Consider a system of n charges. These are the different charges, and due to these charges we calculate how much is the electric field at P. These charges are Q1, Q2, Q3, Q4, Q5, etc. Wherever we calculate the electric field, here we calculate the electric field at P. Imagine a unit positive charge is placed. Due to each charges, the unit positive charge experiences a force. Imagine these charges are positive charges. Now, due to Q1, unit positive charge is repelled. This is the direction in which unit positive charge is repelled, and the distance between Q1 and P is R1. The force with which unit positive charge is repelled, let it be E1. Similarly, due to Q2 charge, unit positive charges repelled, and this is represented as E2. Due to Q3, unit positive charges repelled in this direction, and the force is represented as E3. Due to Q4, this unit positive charge is repelled, and that force is represented as E4, etc. Again here plus Q5 is also there. Due to that plus Q5, the unit positive charges repelled, and that force is represented as E5. Similarly, if n number of charges are present, all the n charges exert force on this unit positive charge. So the vector sum of all these forces will be the net force experienced by P. Since unit positive charges placed at P, these forces are represented as electric fields, electric field intensities, E1, E2, E3, E4, etc. Now let us calculate the net electric field E if the whole system is placed in free space or vacuum medium. Let us see what are these forces. We write E1 according to Coulomb's law. E1, the distances let us note here first. Q1 is at distance R1, Q2 is at distance R2, Q3 is at distance R3, this is R4, and this is R5. So we represent vector E1 as 1 by 4 pi epsilon naught, since the medium is free space, into due to Q1, how much is the force experienced? That's a field at P, E1. So E1 is equal to K. q1 into plus 1. So I write here q1 into plus 1 divided by the distances r1 square, and it is in this direction towards r1. Similarly, we can represent E2 as 1 by 4 pi epsilon naught q2 into 1 by r2 square into unit vector r2. These are all the modulus. Simply if you write r1, r2, or we can write in modulus. Then what is E3? These are all the vectors. E3 equal to 1 by 4 pi epsilon naught q3 into 1 by r3 square into unit vector r3, and q4, q5 and all the other charges experience the forces or fields in the similar way. So let us write etc. etc. So if n charges are there, the field due to nth charge is represented as 1 by 4 pi epsilon naught into qn into 1 divided by rn square unit vector rn. So we had represented all these fields, individual fields due to the charges q1, q2, q3, etc. Now let us calculate the net field at P due to all these charges. So we write it as vector sum of all these fields E1 plus E2 plus E3 plus etc., which is equal to 1 by 4 pi epsilon naught q1 by r1 square unit vector r1 plus 1 by 4 pi epsilon naught some magnitude, whether here I can put the modulus or inside also, q2 divided by r2 square into unit vector r2 plus 1 by 4 pi epsilon naught q3 by r3 square unit vector r3 plus etc. up to n number of fields, or q1 by 4 pi epsilon naught into unit vector r by r1 square plus q2 by 4 pi epsilon naught unit vector r2 divided by modulus of r2 square plus q3 divided by 4 pi epsilon naught unit vector r3 modulus of r3 square plus etc. In all these terms 1 by 4 pi epsilon naught is common. Take it out. So this is equal to 1 by 4 pi epsilon naught into q1 by r1 square into unit vector r1 plus q2 by r2 square into unit vector r2 plus q3 by r3 square into unit vector r3 plus etc. Or in other words, if we generalize the equation, this equation can be written as 1 by 4 pi epsilon naught, which is common, summation qi modulus of ri square into unit vector ri, which is the expression for electric field at point P due to a system of n charges. So if you want, we can represent the I value also. I can have values starting from 1 to n. Thank you.